So, we're back to continue our presentation and discuss the risk management strategies and measures. So, risk management strategies and measures. A large variety of approaches for dealing with risk exists. Although the choices may be infinite, there are generally a few principal management strategies which can be distinguished, namely the avoidance or elimination of risk, the reduction of risk, the transfer and acceptance of risk. The aims for risk management can be accomplished by employing numerous strategies, which in turn use different ways and means that vary considerably depending on the situation and the system. The term risk management measure is the most generic term representing the wide range of methods, techniques, approaches and tools for managing risks at a more operational or tactical level. Some of the many different current terms in use are risk control measures, preventive, reduction and mitigation measures, safety measures and countermeasures, while also alternative actions and options. More particularly, as mentioned earlier, risk evaluation requires the determination of the level or significance of estimated risks which may fall into one of the following risk regions. For risk region, generic risk management strategies and measures are designed to deal with risks such as the highest level of risk, intolerable or else the unacceptable region, where risks in this region are considered unacceptable or intolerable and cannot be justified except in extraordinary circumstances. Immediate measures should be undertaken to eliminate or at least reduce risks at the acceptable, tolerable level irrespective of costs. Moving down in the graph, we have the as low as it is reasonably practicable or tolerability region, where risk in this region may be considered undesirable, in particular those that lie in the upper boundary, but acceptable as we move downward to the tolerable risk area. Undesirable risks may only be acceptable, tolerable, if the risk reduction strategies and measures are impracticable or if the costs are disappropriate to improvement gained. Finally, as we move to the lower risk level, we have the broadly accepted regions where risks are considered negligible and broadly accepted. There may be no need for detailed work to demonstrate the as low as reasonably practicable or tolerability region. However, it is necessary to ensure that risks remain at this acceptable level. Moving on, the strategy of risk avoidance and elimination. This strategy involves the elimination of risk at their source. The strategy may, for example, include the elimination of chemical-related activities from banning production and transport of chemicals, transport or distribution hazards and the elimination of transport or distribution hazards and their effects through the design and manufacturing, let's say, of stronger and more secure packages for the carriage of materials and chemicals, while finally the elimination of causes and contributing factors of accidents and incidents involving dangerous goods releases and subsequently their effects and consequences. Then we move on to the risk reduction management strategy. This type of strategy aims towards reduction, but not a complete elimination of the frequency of occurrence of undesirable events and the severity of their consequences. There are numerous risks that cannot be eliminated in a technology-based society like ours, including production, transportation, storage, handling and usage of many dangerous goods as chemicals. At least currently, and in the near future, complete elimination of most risks in the transport of dangerous goods may not be possible, as this may be very costly, practically difficult, or not feasible at all. Moreover, contemporary societies rely heavily on the use of a wide range of dangerous goods, and subsequently it desires the benefits of activities related to these. With respect, more particularly, with respect to the benefits of chemicals, the European Union's White Paper on the Strategy for Future Chemicals Policy in the European Community states characteristically that chemicals bring about benefits on which modern society is entirely dependent. For example, in food, production, medicines, textiles, car, and in other sectors and industries. They also make a vital contribution to the economic and social well-being of citizens in terms of trade and employment. The chemical industry is Europe's third largest manufacturing industry, because as it employs more than 1.7 million people directly and up to 3 million jobs indirectly. So, given the benefits of chemicals in many countries and industries, efforts have been made to reduce dangerous goods risks to an acceptable level. Risk reduction can be achieved by reducing the frequency of occurrences of dangerous goods release events and the severity of their consequences should they occur. These include two essential approaches to risk reduction, namely, firstly, the prevention, and secondly, the mitigation. Prevention means to hinder undesirable events or keep them from happening, especially by taking precautionary measures. Preventive risk control requires risk control measures in order to reduce the possibility of the undesirable events, while mitigation means to make undesirable events less severe, harsh, or moderate. Mitigating risk controls requires risk control measures to reduce the severity of consequences of undesirable events or subsequent events should they occur. Because of the increased complexity of interrelated elements of the systems and the large amount of various types of dangerous goods carried by water, an absolute elimination, which is hindering all dangerous goods release events, is not possible at the moment. So, reducing the frequency of consequences once dangerous goods have been released also reduces risk. For example, in order to reduce risks on board ships, measures can be taken to contain flammable or toxic spills to prevent fires and explosions. The risks can be also reduced by timely responses in evacuation of people, passenger and ship personnel that are likely to be exposed to dangerous goods hazards. The approach of reducing the frequency of occurrence, such as causes, contributing factors, hazard release events, and exposure, constitutes prevention, also known as a loss of accident or accident prevention, whereas minimization of the severity of the consequences once the release or involvement of dangerous goods has happened and the risk receptors are exposed to dangerous good hazards is generally known as mitigation. Further on, moving to the risk transfer management strategies, we have to say that risk transfer is carried out in many different ways, including risk transfer by insurance and contract, and risk sharing and physical transfer. With regard to the transfer by contract, organizations may transfer insurable risks to a third party under a legal contract. These risks are known as contractually transferred risks. In the shipping industry, for example, charter parties, bill of lading and other contracts, sale and purchase of goods, stipulate rights and liabilities arising in case of marine accidents and damages or losses of goods, including dangerous goods. With respect to transfer by insurance management strategy, we have the purchase of insurance and reinsurance, which is the most common form among the various types of transfer risk can take. Nowadays, more risks have become commercially insured. In some industries or businesses, insurance is one of the most developed areas of risk management. Risk transfer is mainly based on cost-benefit considerations. The cost of insured risks consists of insurance premiums, fees, commissions, and other administrative costs. For example, in the shipping industry again, the risks are insured by risk carriers such as insurance companies. Approximately 90% of the world's merchant fleet by tonnage is bound into mutual non-profit making structure which is made up of the P&I clubs into which ship owners pool their third-party liabilities. Such liabilities include those arising from the ship, cargo and other property losses and damages, personal injuries, or pollution liabilities should they occur. A third way of transfer risk management strategies is the risk-sharing strategy. In many countries and industries, there are numerous risk-pooling agreements providing for organizations the possibility to cooperate in reducing and sharing risk costs. In addition to the actual sharing of claims and the pooling of premiums, the essence of this pooling is also sharing of the services provided by the SIM management. While finally, moving to the physical transfer management strategy, we have to say that risk transfer by contract or insurance concerns transfer of risk costs and responsibilities, but it may not necessarily concern physical transfer of human, environmental, or property risks. Physical transfer of risks takes many different forms, including the transport mode or activity, whose purpose is to reduce the frequency of dangerous good releases or the severity of their consequences. For example, modal transfer involves transfer of risks from, let's say, air to the next transport modes within supply chain, such as maritime, road, or rail transport. The carriage of many dangerous goods is prohibited by air, but permitted by other modes of transport. Risks are also physically transferred, for example, by diverting the route of transport means, with dangerous goods from high to less sensitive and dense residential areas. Finally, we have the management strategy of risk retention. Risk retention means that certain risks are to be retained as they cannot be avoided. In some situations, risks, however undesirable they could be, cannot be avoided, reduced, or transferred, as this can be economically or practically impossible. The decision makers may have no other choice than to retain these risks. In certain circumstances, no active response may be a solution. Additionally, even after reducing risks at a given level, some risks may still retain. These are known as the residual risks. These types of risks may be considered as insignificant or negligible, and further reduction may be very expensive and counterproductive. Risk retention does not necessarily mean doing nothing. However, also doing nothing means taking some kind of risk. Although risks retained may be at a negligible level, where no actions for changes or improvements may be needed, the decision makers should still need to commit considerable time, resources and efforts to maintain these risks at the current level. Finally, self-risk, which is also known in the insurance industry as deductibles, is another form of risk retention. Another form of risk retention is self-funding or self-insurance, in which certain organizations may fund insurance claims from their own reserves. This means that claims arising, for example, from serious accidents may be funded from the reserves of the organizations. In some industries and sectors, self-insurance has been used for many years as a means to take control of insurance. Moving on to the risk management measures, the variety of possible measures to deal with risk is also endless. However, based on the understanding gained through the literature, risk management measures are categorized based on the purpose of enactment, legal aspects, and their nature. First of all, we have the purpose or strategy of enactment, where risk management measures can be preventive, measures to reduce the frequency of accidents, or mitigating. Examples of preventive measures are technical and operational measures to eliminate or reduce releases of dangerous goods. Rescue services and contingency planning are examples of mitigating measures. With respect to legal aspects, we have to say that from a legal point of view, measures can be divided into, firstly, regulatory or mandatory, and secondly, non-regulatory or voluntary measures. Regulatory command and control measures include all categories of legally binding measures, for example, technical or operational. The transport of dangerous goods is highly regulated, while a large number of responsible authorities and parties are assigned to enforce compliance with regulations. On the other hand, product stewardship and environmentally friendly product design, employee health and safety programs, information and education programs to modify people's behaviors and promote marine pollution prevention are voluntary initiatives developed with the purpose of reducing risks from chemicals. For example, the European Commission in 1996 published 62 recommendations on the development and implementation of environmental agreements with the aim of enhancing the effectiveness of voluntary agreements. Risk management measures according to the type of measures. The following are some paradigms of risk management measures by type. With regard to information and knowledge, for example, we have risk communication programs, information tools such as the classification and labeling system, the dissemination and sharing of risk-related data and information, dissemination and sharing of risk assessment results, while also public hearings. On a technological level, the use of the best technology available requires the use of the best technology available, including hardware, meaning chips and packaging, software, where includes risk analysis, assessment of software tools, information technology, and communication solutions. While on an operational level, we have, for example, packaging, storage, loading, discharging, carrying, or even transport, documentation, and security. A single measure can be utilized to affect one or several combinations of risk or system elements. On the other hand, multiple measures can be designed to affect a single element. Often, however, there is no single option to guarantee a high level of safety and health, environmental and property protection. As a single measure may be insufficient, several measures are often combined to accomplish the risk management strategies. Now, moving forward to some risk analysis techniques utilized in the risk management processes. Risk analysis techniques are utilized as analytical tools for analysis of risk-related data and information. Some techniques center on the analysis of a specific risk element, like hazard identification, whilst others are better to be used for the analysis of various systems or risk elements. In some cases, techniques are employed as additions or integrated elements of the risk assessment frameworks. A brief presentation and overview of some risk analysis techniques, along with their application and processes, will be undertaken in the next slides. First of all, techniques is among the series of techniques is preliminary risk analysis. Preliminary risk analysis is a systematic approach whose primary aim is to recognize and distinguish the risk associated with accidents that may occur during operations. This is a team-based approach that relies on a systemic investigation by experts and leaders of a wide variety of issues related to a system or activity. A standard form worksheet is to be used for the analysis. These are some categories of information that are produced during the analysis process, such as the identification and description of accidents, qualitative descriptions of probable problems, mainly the causes and their contributing factors, including the major contributors to accidents, current safeguards in practice, quantitative estimates of risks, while also a list of recommendations for minimizing risk, and quantitative assessment of the effectiveness of recommendations. This technique is utilized for the generation of risk profiles across a wide range of activities, including activities in seaports such as the loading and unloading procedures. Moving on to another technique which is called change analysis. Change analysis is a technique that is utilized to systematically investigate potential risks in order to identify the proper risk management. So, again from the beginning, change analysis is a technique that is utilized to systematically investigate potential risks in order to identify the proper risk management strategies and measures in changing unfortunate occurrences. The technique is implemented to systems, operating practices, and policies that are changing. It is also implemented in new actions that will be undergone and which may contribute to an actual accident or may introduce supplementary of new risks. For example, the analysis may focus on how changes in the system influence the outcomes. This can be used as a source cause analysis method in accident investigations, as well as a proactive risk analysis technique in changing situations. Implemented along with other techniques such as the preliminary risk analysis illustrated above, the change analysis can be utilized to identify alterations in the overall risk profiles in a system or activity such as seaports. Further on, we have the Pareto analysis technique. Pareto analysis is a technique that is employed to distinguish and prioritize the major causes and contributive factors or events of accidents. This technique utilizes the Pareto rule, which supports that about 80% of the effects are produced by about 20% of the causes, the 80-20% rule. The Pareto analysis is a tool applicable from an activity or operation perspective up to a system level by ranking activities or system accidents and their causes. This technique can also be employed to assess changes in risks after alterations in the system or in activities have they occurred. Based on statistical data, the Pareto analysis technique can supply quantitative estimates that can be graphically illustrated. Further on, we have the hazard and operability or HAZOP technique, which is actually a technique for the identification of hazards that utilizes a formal, structured, and systematic review of a system or a process in order to recognize probable deviations from normal operations and their causes and effects, illustrate what safeguards currently exist, recommend suitable measures to avoid accidents, while this technique has originally been developed to recognize and assess hazards in a chemical process plant. By utilizing the brainstorming procedures, the technique is employed to identify hazards and operational problems. A multidisciplinary team of experts, under the guidance of an independent HAZOP leader, performs the brainstorming. The HAZOP technique utilizes a standard list of words like more or less or no combined with process conditions, speed, flow, pressure to systematically consider all potential deviations from the normal conditions. For each deviation, potential causes and effects are considered and whether additional safeguards should be recommended. Information is provided in a standard format. Well, finally, the HAZOP technique generates qualitative results. It is mostly used for the identification of hazards and operational problems in the processes of the systems, especially fluid and thermal ones, during procedures and sequential operation. While also we have the event tree analysis, the ETA technique, which is an analysis technique that models a wide range of potential outcomes of one or a group of initiating events. This technique describes safeguards called lines of assurance and investigates how these safeguards and external influences affect the chain of events. The ETA technique is utilized to provide qualitative descriptions or, when significant amount of data are available, quantitative estimates of occurring frequencies of various failure sequences and contributing factors. The scope of quantification is to get the structure of a tree where each branch can expand exponentially, but omit the stage of quantifying the branch frequencies. The quantification requires significant amounts of statistical data and is generally time-consuming. This technique, though, also provides recommendation for managing risks. Event tree analysis can be used in any type of risk analysis, but is mostly utilized to model events where numerous safeguards are in place to prevent or interrupt escalation of events. So, any event tree analysis consists of a number of elements amongst which we can distinguish the initiating event, the occurrence of certain failures that create events with undesired effects, the line of assurance, the safeguard protective systems, or human actions that prevail to prevent the initiating events and interrupt their escalations, while finally the accident sequence or scenario where specific pathways through which the initiating events escalated to events with negative events. While finally we have the fault tree analysis, the FTA, which is a technique that models potential combinations between system elements such as equipment failures, human errors, and external events and conditions leading to certain accidents. The fault tree analysis technique relies on the backward search method utilizing the logic tree of the relationships. The analysis illustrates how hazard events can occur through the escalation of a single or a combination of a wide range of latent initiating events. It also illustrates the existing safeguards and how they can fail to prevent escalation of events. Fault tree analysis is applicable again for any type of risk analysis, but it is utilized more effectively to analyze accidents or issues that are characterized by a large number and complex combination of events. It can be employed as a tool to comprehend the most important factors and determine the real root causes of the accidents occurring. This technique can generate qualitative descriptions, and when significant amount of data are available, quantitative estimations of the risk elements are also possible. Finally, in qualitative and semi-qualitative approaches, quantitative approaches, it may not be necessary to estimate frequencies, as the tree structure is considered to be sufficient to illustrate the framework in which events occur. The FTA procedures include the following major steps, where to begin with, we have the definition of the system or activity of interest, the definition of the top or initial event, and the definition of the top structure of the tree, the exploration of every branch of the tree structure in detail, the solution of the fault tree for potential combinations of events, while also the identification of important failures, quantitative analysis, and finally, recommendations. This brings us to the conclusions, where we can say that the purpose, we can make concluding remarks with respect to the risk management system. The purpose of risk analysis is to provide answers to the fundamental questions concerning risks. It provides decisions or policymakers with useful and logically structured inputs and perspectives about risks, as well as recommendations for a better risk management. Risk analysis and assessment, as well as other elements of the risk management system, is generally a systematic and rigorous scientific process that is usually facilitated by frameworks or techniques. Risk analysis is in principle a well-structured scientific process which is facilitated by specific risk frameworks and techniques. The presentation showed that one framework or technique may not offer a perfect suit for all situations and systems. Therefore, one size does not fit all in the current procedures. In many situations, several strategies and measures are often combined to achieve efficiently and effectively risk management goals. The quality, quantity, diversity, availability and accessibility of risk-related data and information are prerequisites for validity and reliability of risk analysis results. The review of many databases and risk studies show that risk-related data and information is inhibited with a wide range of issues, while finally, almost all risk management strategies and measures involve risk. It may be nearly always possible to take measures that would reduce risk further, but the costs would outweigh the expected benefits. Further strategies and measures can be practically or economically impossible, if not counterproductive. Therefore, in many cases, a balance between costs and benefit is needed. So, this is the end of the first session. Thank you very much for your attention. The next session will begin in 45 minutes. Thank you very much.